Almost any voice agent twice, and they're going to greet you like a total stranger every single time. No idea who you are, no memory of the last conversation, no clue about your account information, nothing. So today we're going to fix that. By the end of this video, your LiveKit agent will know who is on the line, answer from your own knowledge base, and remember what was said last week. All powered by MongoDB Atlas Vector Search. I'm going to walk you through a working starter kit with 5 different patterns that make it work. And so you can clone it, modify it, and ship it. The links are in the description. Now, voice runs on a much tighter latency budget than chat. In chat, if you have a 2-second pause, you likely have a spinner or some way of knowing that the agent is working. You know it's going to get back to you. We're used to that. But in voice, 2 seconds is really a long time. And so that sounds broken. So anything that the agent remembers or looks up, it has to fit inside one round trip. So 3 jobs that benefit from leaving the prompt and living in a database are knowing who is on the call, answering from a knowledge base, and remembering what was said the last time. MongoDB Atlas handles all 3 of these in one cluster because the document model fits profiles and transcripts, and vector search runs right next to that data. This MongoDB template is based on official LiveKit templates. There are 2 agent templates, one in Python and one in TypeScript. And so they add MongoDB for the async client and Voyage AI for embeddings. There's no STT, LLM, or TTS plugins because LiveKit inference handles all of that through your credentials. And then there are 5 environment variables that you'll need, 3 LiveKit API keys, your MongoDB connection string, and a Voyage AI API key. So again, everything just routes through LiveKit inference, your speech to text, your LLM, your text to speech models. You don't have to have an OpenAI API key, for instance. You can use any model that you'd like for any of from any of the providers by just swapping out a single string in your agent. So let's take a look at the 5 different patterns that are in this template. Again, we've got a Python agent, a TypeScript agent, some database helper functions here, and then our front end code. For the code walkthroughs, we're going to use Python. And so if we go down into our agent, we're going to look at the first pattern here, RAG. It's just a function tool here. So because of the instructions that we've given our agent, it knows when it needs additional facts. So it's going to use this simple function tool to use RAG, a retrieval augmented generation, to gather more facts. And so this is not something that we run on every turn. So first we embed the query using Voyage AI, and then we run a vector search aggregation pipeline against the knowledge collection, and then we project the title and the content, and then we await that data to return. So down in our agent class, we have this function tool, and this is where we are actually using our search knowledge tool that we created above. And then in here, one thing to highlight is this status task, where we are going to speak a status update every half second. So this is one trick worth copying here. A tool call adds a round trip. And so in voice, that equates to silence. So we schedule a short verbal update every half second and then cancel it down here in the finally block. So when the search finishes, it gets canceled. And so if it's a really fast search, then there's never any filler. And if it's slow, then the agent is going to say, like, give me a second, and then answer the question. So we go here to our speak status update. We can see the instructions. We're telling it, you're searching the knowledge base for whatever, but it is taking a moment. So give the user a brief 1-sentence update that you are looking it up. So again, in a text chat, we've got a spinner or some shimmer text or whatever going on. We know that it's working, it's doing something. In voice, we don't have that. So we're giving that update here just so that the caller knows what's going on. Now, moving on to the second pattern, agentic memory, we have another function tool called remember detail. So RAG covers facts that already exist. Memory is what the agent picks up mid-conversation. So we use this, we model this as slots. So each user, tenant, and memory type holds one value. And so writing the same label twice updates it, it replaces it. So that matches how voice actually uses memory. So your current favorite color is not a log of every favorite color you've ever had. It's just the current one. And so we embed the type and the content together. And if we take a look at this remember here, So this is in our db memory.py file. And here's where the embedding happens. And then we are waiting update 1. And here's where we are setting that memory. And then upsert is true. So if it's not a current memory, it gets created. Now the catch is that the exact label recall only works if the model remembers the label that it used. So retrieval or search for this is hybrid. We'll use rankFusion here to run a vector search pipeline and a text search pipeline in parallel, and then merge them with reciprocal rankFusion. And so we weight it 70-30 towards semantic match while keeping lexical precision for direct hit. We've got our two pipelines here, our vector search and our text search. Here's our weights, and then we are returning whatever memories match that search. So back in our agent py file, if we go down here to this function tool here, we have another tool called search memories. And so this is where we're using that database function here to then search memories based on whatever query the user has asked. Now for our third pattern, it is identifying the user and preloading data. So to do this is going to be in our front end, our API call there. So if we go over here into front end, app, API, route, before we load a profile, we need a stable ID. And so it has to reach the agent before it speaks. So this token route will own the identity. So it reads an HTTP only request here and creates a cookie. So it mints a new UUID if none exists, and it stamps that ID onto the agent dispatch metadata. The client cannot read or forge it. And so any room config that the client sends is going to be ignored. On the agent side, we have this preload user function. And here we're using DB users, find one, and update. On the agent, we parse the job metadata before connect. So the profile load runs in parallel with the connection handshake. The preload user upserts a user row with a find one and update, and then seeds the chat context with the profile and every memory slot for that user. We go in here and we get all of that context and then the memories, and then return that as chat context. So the previous facts will be in context with no extra tool calls. This again is done at the very initiation of the agent. And so going back to the route, it's called out here at the top. This route is not secure. This is not authentication. This is identity. And so in production, you would want to swap out this cookie read for clerk or better auth. This is just a quick way to demo how this pattern works. Now for pattern 4 is another function tool for CRUD, create, read, update, and delete. So we have a function tool here that is for looking up an order. Now for data that the agent reads or writes on demand, a plain function tool is the right surface. Here we look up an order and we'll raise a tool error if there is no order found. And so this message goes back to the model so that it can apologize for not finding an order and ask again instead of it just crashing the program. Now for anything that writes to the database or causes a mutation, we could add disallow interruptions. And so this allows us to make sure that that write happens, and even if the user tries to interrupt the agent, and then we read back the confirmation. Now for the fifth and final pattern, we have session persistence. So when the call ends, this on session end will hand you the context to build a session report and write that to a sessions collection in MongoDB. So the user and the tenant, they come from that same place that that pattern 3's stashed them in MongoDB. And then the report dict here gives you a JSON-friendly snapshot. And so a few hundred calls becomes a corpus that you can then aggregate without leaving Atlas. So again, this saves time, which means less latency. And so this was just an overview of some of the things that are integrated into this template. You can check them out, run them yourself, modify them how you see fit. But let's get it up and running. So in the main package JSON, you can see a bunch of scripts here. So again, you'll want to run the setup, install on the front end, the back end, whether you want Python or TypeScript. And then you've got your different dev commands here to run either the Python or the TypeScript agent and the front end. And then there are also some database initiation scripts as well. So db init to add our indexes to the database, and then seed to add some dummy data. And so those are here in the DB. And you can see here indexes that are going to be created. Of course, we have a vector index and a text search index as well. And then seeds, which is basically, again, just seeds some dummy data. And you can see the actual data here in the data TS file. Let's go ahead and run this and give it a try. pnpm dev, and let's do the Python version. So this is going to boot up the agent and the front end both. So let's just go to localhost 3000. Let's start the call.
Hi there, I'm your MongoDB Atlas backed voice assistant. What's your name?
My name is Jesse.
Nice to meet you, Jesse. How can I help today?
Yeah, what can you help me with?
I can help with a bunch of things. I can look up orders if you have an order ID, remember your preferences, and answer questions about voice agents, MongoDB Atlas, or related tech. I can also keep track of details you share, like your time zone or favorite settings, so things feel more personalized. What do you want to try?
So remember that my favorite color is blue.
Got it. I'll remember that your favorite color is blue.
Awesome. All right, cool. All right, so I'm going to end the call. Let's refresh the page, and we're going to start the call again and see what it remembers.
Hey, Jesse, good to hear from you. What can I help with today?
Yeah, what's my favorite color?
Your favorite color is blue.
Okay, actually update that. I would rather you remember my favorite color is black.
Got it. I've updated your favorite color to black.
Awesome. All right. So in the call again. Let's start. See if it remembers.
Hey, Jesse, nice to talk to you again. What can I help you with today?
Yeah, what's my favorite color?
Your favorite color is black.
Okay, cool. Thanks for remembering. So clone the starter, point it at a MongoDB Atlas cluster, and you'll be talking to a memory-equipped agent in under 10 minutes. Links to the repo and the docs are in the video description. If this video was helpful, give it a like and subscribe for more voice AI content like this.